Good morning, everybody.
And today we're going to be talking about the FEMAP 11.3 new features. There were a few things added that really benefit the user experience here. So we're going to go through them. We'll show how to use them in some situations where they'll really simplify your analysis. And well, we've got some interesting models here to try to keep it interesting. Before we begin, we've got a couple words from Eric Barber here.
Good morning, everyone. As hopefully most of you know, I'm the account manager here, and just wanted to throw out, as you can see from the slide attached, obviously we feel strongly that we've got the best FEMAP sources available on the planet for our and then that, of course, is coupled with what we think is some outstanding technical support, as you can see from the testimonial there from our good friend Nathan at Bristol Harbor Group. Along those lines, just giving you a heads up in terms of we will soon be limiting our access to our FEMAP resources to those folks that are not a current customer or client. If you're a current customer, just giving you a heads up that if you run into any login issues, restrictions, obviously give us a call immediately and we can rectify any issues along those lines. Most likely it's using a personal email instead of a company email account. But if you are someone that's, like I said, if you're current with active maintenance, you're going to have full access to all our FEMAP resources going forward, which obviously we think is a huge advantage to being a FEMAP customer of ours. And then, of course, that comes with the technical support from, as I FEMAP gurus, Adrian, George, and Kyle here. So you'll see this transition coming in the ensuing weeks. If you wish to become a client, feel free to contact me. You've got my email address and my phone number there. Typically, there's no cost associated with moving maintenance, and this is obviously available to those folks in the U.S. and Canada. And hope to hear from you soon. All right, turn it back over to Kyle and Adrian. Thanks.
All right, hi everybody. So I'll be running through the examples here, and Adrian's going to be manning the keyboard and answering questions. He'll try to answer them in text if he can, and if not, we can address them at the end. We should have some time then. So feel free to ask away.
Yeah, if any of you haven't been to one of these webinars before, there's a little dashboard that pops up when you sign in, and there's a questions box there. So you can type your questions in there, and I'll try to keep up as they come in, and Kyle will be running the show. So with that, I'll go ahead and mute myself, Kyle, and just kick things off.
All right, sounds good. So today we've got a little bit of a nautical theme going on here with our models. We've got a couple boats and a trailer to use as their examples. And all of the loads are made up, the sizing's made up. This is purely our new features seminar, so we're trying to get some good examples here for these features. Before we get into the analysis tools that they've added, one of the user interface options that's really helpful in navigating your model is instead of going up here and choosing your view center and your rotation center as you're moving around your model, which can be kind of tedious if you've got a large awkward shaped model, they added this new feature up here in File Preferences. And then if you go to the User Interface tab, there's Zoom around cursor location and Rotate around cursor location. And this is helpful because instead of having to manually set your zoom and rotation center, you can just wherever your cursor is, that's where it's going to zoom and rotate about. So you can rotate about the end here, or if you want to rotate about this end here, you just grab that area. And this gets, it's one of those little things that really helps things along. You don't really notice it until it's turned off, and then it makes you much happier when it's back on. So here we've got our catamaran model. We've got a big pressure load on the side here of the sail. We can turn that off and see things a little more clearly. Down here we've got one side of the pontoon fixed trying to roughly approximate that pontoon being in the water and a large wind loading on the sail to really flex this structure. Of course, this catamaran's only on one pontoon as it's cruising through. So the first thing we're going to look at is the DryErase Toolbar. And this feature is a little bit odd when you start using it, but after you get used to using it, I went back to 11.2 the other day when preparing for this seminar, and the first thing I reached for was a DryErase Toolbar to help me navigate the model. So it's definitely a very useful tool. So let's look at what it does. We've got a couple options here. You can toggle it on and off, and you've got draw mode or erase mode. This lets you toggle whether the entities that you've selected are turned on or whether you're hiding those entities you've selected. And that'll make a little bit more sense once we see some examples here. You can select entities by geometry or by mesh or by area. And if you select your geometry, you've got the breakdown between surfaces, curves, and points. And if you select your mesh, you can select by elements, by properties, or materials. And of course, regions and connectors also. So how does this work? Let's start by selecting some geometry. And let's say I have this whole bottom piece as one solid. And let's say I really want to, for some reason I need to hide this bottom piece. I can select that solid and hit OK. And notice nothing happened. That's because I have the DryErase Toolbar turned off. Turn it on. You can see it toggles that solid and the mesh that I selected off. We can toggle between draw and erase to only draw that solid and mesh, or only erase that solid and mesh. If we want to clear this, just hit this Draw Erase Clear button. You can also select by mesh. One feature I find myself using a lot is select by property. If you only want to turn off one of these pontoons, you can click or double click to use a little shortcut there. And again, you can only draw that, only erase it. And this is, once you work this into your workflow, it can be speed things up a lot. And let's go ahead, we'll say select by elements. And you can use your standard selection. Let's see. We'll grab elements on surfaces, and we'll grab everything on this one pontoon here. Can highlight to preview. Okay. So right now we only erase that. We can also just draw that. And a useful feature in the DryErase Toolbar to really kind of diagnose any issues you're having with your model and see which elements are connected. There's this grow and shrink option. And let's take a look at what this does. When I selected grow, it expands what it's drawing. From those elements on the edges, it searches out and finds the elements that are connected. And notice we originally only selected the pontoon there, but as we grew it out, it grabbed the rigid element, and then it grabbed this thin beam element also. And it'll keep going. You can end up drawing your whole model if you want. Similarly with shrink, you can erase that, and it takes it away as you go. So that's a pretty handy tool. I definitely recommend just experimenting with it. Try to work it in with your workflow. There's some more explanations of the features it has in the help file, so take a look at that. And it can be a real benefit as you're navigating your model. The next thing that we'll look at, which is admittedly not a hard and fast analysis function, but it's really useful, is the property icons. I'm sure you've noticed if you've been using 11.3 for any amount of time that now you've got new property icons, and the property icons correspond to what the property type is. And so you can see these holes are laminate element or laminate properties. And so we've got the little plate symbol with a laminate symbol next to it to denote that this is a laminate. The sail, rigging plate, and frame are made up of plate elements, so those have those little plate symbols. we've got two different types of solid rods in here that are beam elements. And the beam elements actually show their beam cross-section in these properties. And we'll take another look at that in a different model too. And then we've got another plate element here. And so that's pretty handy. It's good to keep in mind when you're navigating your model. And so now let's take a look at some real functions that are going to help with your analysis. They're going to help you make your mesh better and hopefully get better results faster. If we take a look at our sail here, it's kind of a funky shape. And you'll notice if we kind of zoom in, there's a lot of these tries throughout the sail. And if we go up and down, like along the mast, there's a lot of tries. And we're not so concerned about the sail stresses on this model, but in some cases, if you've got round or funny shaped pieces, you might have tries in your high stress regions. And that's really not ideal. If you've got tries in your high stress regions, they're going to be artificially stiff, and they may underpredict your stresses, which nobody wants that. So let's take a look at where these tries are. If we highlight our elements by shape, you can see we've got 169 total in our model, and there's a good handful of them in our sail here. So let's delete this mesh on the sail. Delete it on surface. Okay, and we'll keep all those meshing attributes. And let's go ahead and turn on our surfaces to make this easier. We'll keep our original mesh sizing that we already have. We'll go Mesh, Geometry, Surface. Select the same surface. Okay. Now, on our Auto Mesh Surfaces dialog, we're going to select that we want to mesh it as our sail property, and we're going to use quad elements. And now there's this new option down here called Max Quads. And this is going to mesh your geometry with quads if at all possible. In some cases, you might need like a single try to match up with your mesh sizing, but most of the time you'll get only quads here. So let's maximize our quads, and note up here we're at 152 tries in our model. So let's see what this does. So it's meshed it. We now have 153 tries, and so it added one. Let's go ahead and highlight to see where that one is. Looks like we're up here in the top region of the sail. And if we zoom in and look at some of those areas where we had tries before, you can see it used some quads that are a little bit oddly shaped, but they're still, I don't know, they're not super thin or skewed or anything. And this will get you, if you really don't want tries in your model or in your regions, and you're using auto mesh, this can really help you out there.
I'll hop in here real quick. I'd recommend, the usual process of turning on your element quality contour. What I've seen a little bit with this command is that, yes, it eliminates or minimizes your tries, but sometimes it can, affect the quality of other elements. So it's a little bit of a trade-off whether you want to avoid tries or whether you're willing to accept some quads that are a little bit more skewed. So just pay attention to your mesh quality using this command. It's there's no perfect command, so you want to be aware of the trade-off with this.
Yeah, absolutely. Remember, turn on your element quality, model data contour, element quality, Jacobian, and this checkbox up here toggles that on and off. And you can see some of these elements are up here between 0.7 and 0.85, so it's, yeah, definitely not an ideal way to go. But it's useful to know that it's there. Next up, we can look at this feature. Previously, if you wanted to refine your mesh, you can go in here and select your curves and select how many elements are on your curves. Let's turn off our surfaces here. And if we look down here, we could, if we want to get two elements through the thickness of the surface here, one option would be to grab our meshing toolbox and change the mesh sizing on this curve and then find the curve down here. And that's going to split our mesh all across this bottom surface. There's a new tool that we'll take a look at here. It's called Element Refine, and it's kind of actually fun to use. Let's take a look at it. It's under Mesh, Editing, Element Refine. And you actually can click and paint which elements you want to refine. Notice this one got a little funny there. If you only want to do certain elements on a surface, you don't want to go all the way, you can select that one element. You can select by an area. If you hold Shift, click and drag, you can select a lot of elements on a surface. You can grow the selection, and you can shrink the selection. So let's see. Oh, and you can shrink it all the way to get rid of it, actually. So let's try this out. We will just get this front edge here. Oops, we'll clear that. Okay. Okay, so we've got our front edge there selected, and maybe we'll grow it out once to grab those side nodes there, and I'll select OK. So we'll update those elements live, and you're not constrained by where the edges of your surfaces are here. And this can be, if you want to go even finer, you can select this option down here to split it into a 3 by 3 instead of 2 by 2, and if we do that, you can see it's a pretty fine mesh there. All right, so that's our element refine option, and that's about it for this catamaran here. Let's move on to our next boat. We've got this little dinghy, and this boat, we'll look at some other features. First up, as I mentioned before, we've got this new beam modeling dialog box. Let's expand our model, expand properties, and if you look in here, you'll notice there's the seats are C sections, so you have a little C. We've got some hollow hats running down underneath the seats, and those have the little hollow hat symbol. Mass element uses mass. It's the little things, really. Let's go in and take a look at our property definition. This dialog looks the same as the previous versions of FEMAP. If we go up into our shape dialog, it looks a little bit different. If we click our change shape, we can get access to these tools here. And the big addition is this live updating of your cross-section properties. You've got your area, your moment of inertias, your centroid from the origin, and as you change these values, it will automatically update those, which is pretty handy. Let's change it back to what we had before, 1 by 2 by 4. And sometimes you might want to drop these beam cross sections into a report or something. You can just click it, copy and paste, or you can click down here. Let's see. You can just click one button to copy your section properties to your clipboard, or you just save it as an image. Click that, it gives you your save dialog. Oops. Oh, you'll notice it bumped my beams off to the other side of the boat since I went in there and edited the cross-section. I had altered my z-axis offset here. So we'll just change that back to 0.5 in the positive direction, and Control-G to regenerate a view, and they're back in position. All right, so one of the new features that I have grown to really like, and it's everyone either loves or hates free body diagram. They're actively working to make it a little bit easier to pull your free bodies off of your model. So before we'll do an analysis and look at some of the results, but before we get there, let's take a look at our loading on this thing. we're fixing this surface down at the front, kind of trying to simulate an impact against a wave here. Let's go ahead and show this face. So it's that surface right at the front, and we just have a 3G body load in this negative Y direction. So this thing's hitting pretty hard, and we'll see how this little aluminum boat takes that impact. So let's go ahead and analyze. And if you've used free body diagrams before, you know that in your output requests, you want to make sure you request your force balance and your equation forces in your analysis set. Let's take a quick look at that. So for those of you who haven't used them too much, so your equation force and your force balance, make sure those are checked. They're not on by default. And we've got this output set. We've got some stresses in the boat. It seems pretty reasonable. Down here, there's a lot of stresses right in the area after or behind the loading or behind the fixed area. Let's take a look at some of the free body forces through this structure. We'll go ahead and turn off our contours to make life a little easier. And we'll delete that. I don't want to be cheating here. Okay, so we'll start from scratch. We'll go to a new free body. And we always had free body and interface load. Now we have this new option called section cut. We'll just call this section cut free body diagram. We won't need applied loads, no reaction loads, no multi-point reactions. Let's go ahead and only turn on our peripheral elements. And we can turn on our resultant forces only. And we'll leave our components for total force. Okay, done. So in order to do a section cut, you need to define a plane that you're going to be cutting through on your structure, and then you select your location. So let's go ahead and choose our plane, and we're going to do the YZ plane because we want to chop down the boat. And let's just choose, oops, snap to node. Oh, I've got my selector on for some reason. So let's just start at 0, 0, 0. The origin's back here at the end of the boat, so we'll put our plane at 0, 0, 0. Now we have this location slider option here. And as you move your location slider, if we turn on our free bodies, so as you move this location slider, it will shift your free body diagram around your structure. These arrows are a little large, so we can go ahead and drop them down to a little smaller size there in our view properties. And so what this is doing is you've got your plane that you defined, and then wherever your plane is cutting across the structure, it highlights those elements, and then it's just updating those element selections as you move down your structure. And so if we drag it down to the end, you can see it's highlighting all those elements up to that point. If we turn off our nodal vectors and have only our total force vector, we can see it just moves that total force down the structure. And you can see the direction and the magnitude of that force. One thing to be careful of if you're doing your total force instead of your magnitudes, or instead of your nodal vectors, is, for example, this area, we can look at it from the side. We've got a nice clean mesh of this direct line that the plane is cutting across. But if we move back to the other area of the boat, it's not necessarily a straight line that it's selecting. And so you might get some funny forces based on where or what the elements look like that you're chopping at. So just be aware of that. And you can also see the nodes that it's selecting. So it's grabbing the nodes right around where that plane is at on the edge of those elements. All right. Very cool. So next up, we've got our contour arrows. This is a new way to show our beam, or it's a new way to show your contour vectors, and it's especially useful for when you've got beam elements in your structure. So let's turn off our free bodies. We don't need those for now. And we're also going to turn off our thickness. Just make note that these seats across the structure and these hollow hat elements are all beam elements. So we'll take a look at some of those forces. So thickness off. We're going to contour and then select your contour arrows. This looks a little scary. We've got our plate bottom von Mises selected as our output vector, so we'll change that to our beam forces. So let's start with beam end A axial force. All right, we're getting somewhere now. Let's also cruise down here in our contour options. And instead of showing our resultant in this arrow display mode, I'm going to choose to display the axial force, which is that local x direction on the beam element, and then combined shear force. And it's going to combine the plane 1 and the plane 2 shear and display the resultant of those combined. If that sounds confusing, take a look at our beam seminar. We go into a little bit more depth about your beam directions and the local coordinates at your beam elements. Let's go ahead and turn on our arrow labels. It's a little crazy if we're zoomed out, but as we zoom in here, looks like we've got our legend capped at 20,000. We're going to change that back down to automatic, so we get a little bit more color in our beam elements. And so as we look in here, you can see these forces and the axial forces on these seats are negative values. Of course, they're all equal because they share the load. It's going to be, they're all in compression at 44 pounds force, and the shear values change depending on where you are in the beam structure. If we move up here, you can see this second seat is also in compression at 3 times the force, and this front seat is in compression slightly less than the 156 pound force that the second seat had. And so if we've got our structural elements here that are these seats, we're seeing that they're in compression, not in tension, and that they all have a small shear force on them, but really not a whole lot. This gets really useful when you're modeling when you're idealizing bolts using beam elements, because most of the time when you're sizing bolts, the two values that you need are your shear forces, your combined shear force, and your axial force. And so this is a quick and easy way to display that. If we go down here to our hollow hats at the bottom, let's see. You can also pull the forces off of these guys. And these guys are in tension. On one side, compression. Yeah, so give that a shot if you're using beam elements in your structures. This is a better way, I believe, of displaying these than what we previously had. I remember I was pulling shear and axial forces off of bolts about a week before 11.3 came out, and it was a 10-step process. So it was doable, but this is 3 clicks and you're there. All right. Let's see. So that's it for our little dinghy. This model's actually we'll contour. No, we'll save that for the trailer. All right. Next up, we've got our trailer model here. And continuing with our boat theme, we've got a trailer with this mass element representing a boat connected to the trailer using an RBE2, so we make sure we don't add any stiffness to the structure. We've got at the end here is pinned, And then we've got some little brackets glued to the frame and then these brackets are connected to some C-bush elements to represent the springs and the tires connecting it to the road. And notice the constraints on these tires they're not constrained in the X direction, so they're free to roll forward and back, similar to how a trailer would really behave. Let's take a look at our properties again. We've got this cool little C-bush symbol there to really help show that. All right, so first we'll take a look at this this new feature for selecting elements. There's a new face picking dialog box in 11.3, and we'll build on our previous learnings by using this DryErase Toolbar. We'll select by property and only show these brackets. So I selected that bracket property, double-clicked, and it's only drawing them. We can also only hide those, but we'll stick with drawing. If we wanted to make sure we get those little rigid elements that are in here, we can grow this thing out. Continue to grow it to get our C-bush and our constraints and nodes attached to that C-bush. But we'll go ahead and shrink it back down because we don't want those elements in there. Oh, live demos, of course it's not working. So I guess we can't shrink it down from there. Maybe that constraint's holding on to it. So let's take a look at some of these connections that we have in this model. We've got our glued connection property, we've got our connection regions, and we've got our connectors. We have 6 brackets, only 5 connections. We can highlight these to see what we're connecting. Looks like we've got all of them except this last corner bracket here. So we'll zoom in, and we need to create a region for this bracket, and then we're going to create a connector. So let's go ahead, right-click, connection region, and we're going to pick by elements on here. We'll call this one bracket, oops, got caps locks on, bracket 6. And we could go in and select each element one at a time. That's a little tedious. Oops. We'll reset that. We're going to click Add Multiple Elements. And this is the new face selection dialog that they've included with 11.3. The only new method that was added was this individual faces button. So you can select, I don't know, if you want, oops, if you only want that face and that face, maybe you have little dabs of glue holding this thing on, you can select that. But we're not going to do that. We're going to select our adjacent faces. We've got an option to choose what elements we want to select from. You can leave it as at default. It selects all the elements in your model. We can just choose the elements that we've got in our area, and that might speed things up a little bit if you've got a massive model, but you know that all the things you want to select are on this little region. Just choose that. So we're choosing adjacent faces with a 20-degree tolerance, and we'll just select one of these faces. And we can highlight, and you can preview which faces it's selected. You can tell it only choose the faces with matching normals, your front face or your back face, or you've got some more. You can select, if you select more, it kind of holds those faces you've already selected, which you can preview, and then you can select another set of adjacent faces. So just for fun here, we'll select that, and if we preview again, you can see we've got that side set of adjacent faces. Oh, interesting. So now we can't clear those faces that we've already selected. So once you hit more, you're done. You have to cancel out and restart if you only want a certain region. So let's go ahead and do our add multiple element faces, highlight to preview. We've got our 64 faces that we want, and select OK. So we've grabbed all those element faces. We can preview again just to make sure we got the right ones, and select OK. We've got our bracket 6 up there, so we can close that and create our connector. You can always work from the tree here, create our new connector, and select all of your information there. Let's take a look at the new way to do it in 11.3. This model is kind of borderline on whether it's useful or not, but it's a little bit more manageable since this model is not that big. So this is the Connections Editor dialog. It's up here in Tools, Connections Editor. If you've used the Data Surface Editor or Data Tables, this will look really familiar. And this lets you manage your connections using this table format, which can be a lot easier than going through your tree if you've got tons of different connections, tons of different properties. You've got your different options. You can show hide columns. You can add headers, expand them all. You can filter. And if you want to create new connections, you can do that in here also. So let's right-click on the Connections Editor, New Connector, and we'll call this one B6. Our target will be our trailer, and our source will be the bracket. Select OK, and you'll notice it got added to our Connections Editor list up here. Okay, we can cancel out of that. We've got our connections. If we had multiple properties, you can go in here and do that, or change that here. If we wanted to create a contact property, we can create our contact. We'll add some friction. Select OK. And let's say we want connection 2 and 5 to just have contact. We can do that here. If you want to quickly turn a couple of them off, you can uncheck them, and notice down here in our model info tree, it turned them off in our model info tree also. I haven't ran this with contact yet, and I think it might error out if I do that, so I'm going to go ahead and turn that off and go back to our glued connection. So we've got our 6 brackets glued onto the bottom of our trailer. We can close that. Let's go ahead and clear our DryErase toolbar so we can see our whole model again. And let's analyze. And we're going to do our 1G cornering load. So you see we've got our 3 to 6 inches per second in the positive Y direction, and same thing in our positive Z direction. So let's see how this thing does. All right, our output set is complete. It's a pretty quick model to run. All right, let's see. We've got some stresses here, especially over on the right side, which makes sense. Where these cross beams connect to our trailer, we've got some high stresses, and in our little brackets down here, we've got some high stresses. Now, let's say for some reason, oh man, my free bodies are giving me away here. Let's go ahead and delete my free bodies. So let's say for some reason we wanted to see how big of bolts we need on these brackets on this negative Z side. And we haven't modeled any bolts in. We haven't, all we have is this glued connection between the two. So there's actually a new way to pull your glued forces from your free body diagrams. Let's go and we can turn on our free bodies again. We'll create a new free body. New free body. This will be an interface load, and this will be bracket forces. We don't want applied, we don't want reaction, we don't want any of these, but we do want our glue force. We don't really need the nodal forces because this is a pretty fine mesh, and all we really care about is the total force from between that glued surface and the trailer. So let's select OK, done. Of course, first we select our elements, then we select our nodes. We'll select, let's go ahead and select all of the elements on this solid here. Highlight to preview. Oops. guess we can't select on the solid. Let's select on the surface. Can highlight to preview. All right, next up we select our nodes. We'll do the same thing on our surface and highlight to preview. We've got a bunch of nodes there. Select OK. And do we want to auto-locate this vector at the center of those nodes? Yes, we do. All right. This is in a little bit of an odd placement. Let's go ahead and move our total summation vector. We'll just bump it up 5 inches. All right. So this is our total forces between the bracket and the trailer there. You can see we've got 200 pounds downward in this glue force, and then 380 like pulling it off to the side. So based on that, you've got your axial and shear loads bolts there. If we turn on our nodal vectors, you can see that's really not that useful, but it will pull all of your forces off of each element. And this, remember, this is only our contributions from our glue force. So if we turn that off, like we get nothing. So that's our free bodies with our glue force. You can contact if you've got two faces coming together and you want to see what that contact force is. You can do a similar interface load, grab your elements, grab your nodes, and get your contact force between the two. Right now we have it's just glue, so we have our glue forces. So we've got one more thing to take a look at. This one is, I have mixed feelings. I'm still trying to find a good model to demo it, but we'll work with what we've got here. My grand plan was to fly through that little gas tank in the dinghy, but that was a little small for it. So the last feature here is called a roll through. And if you've ever wanted to fly through your models, you'll love this feature. It's good for if you've got, let's say, a large pressure vessel with a lot of stuff on the inside and you really want to get in there. Like if you ever wanted to get inside and see what it looks like, this feature is made for you. In order to turn on this feature, we'll go up to our View and Rotation Center dialog and turn on Roll Through. In addition to that, we need to choose View, Options, and then go to Tools and View Style, Perspectives, and turn on our perspective. Click Apply, OK. And so now I've got Roll Through turned on, Perspective turned on. We're ready to try to roll through this thing. So if you just scroll with your mouse, it will zoom in, and it zooms in on the center of your screen. So let's say we need to take a look at what these stresses are inside this trailer. We can kind of fly through here, and oops, man, bad example here. But you can practice with it. It's kind of a nice way to take a little break from analysis work if you want to practice your flying skills. For this example, maybe you really needed to see the plate bottom von Mises stress around this hole here, and you don't want to mess with your contour vectors. You can fly on the inside and take a look at what this thing looks like. And let's zoom out here. Definitely, I encourage you to try it out, play around with it. In some larger models, it can be pretty useful. I think I saw it demoed on a space station model at one point, and that was pretty cool to see it fly through. Remember, when you're done with it, change it back to rotate about your view center, and also go up to View, Options, and turn off your perspective. And that brings everything back to normal. So that's it for our new features in FEMAP 11.3. we'll have these models up on our website. We've got a document showing how to access all of these features, and so you can try it out on your own. Adrian, do we have any pressing questions that we should answer live here?
I think I got most of them replied all, and we'll attach these questions to the end of our little white paper with this presentation. A handful of questions about the free body diagrams. I think one thing to clarify is if you want to pick specific nodes and elements for a free body diagram, you can do that with the interface load method or display mode. That one's actually was around before the section cut. The other option is when you're working with the section cut, you can actually choose a radius. So if you imagine defining the vector, the normal vector for your cutting plane, you can choose a radius around that vector. So in this example, if we wanted to look at the load transferred between just that center crossbar, we could set up a clipping plane through there and then reduce the radius so that it was only grabbing nodes and elements through that center crossbar. We do have some other workshops, and we've got some short little 5-minute YouTube videos on free body diagrams. So as Kyle was saying, that's always a hot topic for people. So yeah, those are up on the website. You can check those out. It really just takes a lot of practice to figure out all the different clicks that you need with the free body diagram. Other than that, I think we got everyone's questions answered. And as I said, we'll attach those onto our white paper, which should be available on our website probably early next week. So if you want to share this with any of your colleagues, we'll have a recording, the example models, and the video on appliedcax.com.
All right, excellent. Was there anything else you wanted to highlight about 11.3, Adrian?
I think you covered it. Those are my favorites.
Excellent. Well, we'll end a little early here then. Thank you all for hanging in there with us. I hope this was helpful for you and will make you a more efficient and more efficient analyst.
All right. Thanks for coming, everybody.